Hello. I want to make sure people are joining okay. So, all right, this looks pretty good. I'm just going to do the introduction. People can come in, join. You can always ask questions on the right-hand side. So, I'm just going to get started. So, I am Toby Smith with Corero Network Security. I've worked with Corero about 12 years. I've done mostly things with the analytics platform, some product development, product design, training, other things. Background before that was as a network engineer. Before that, I used to train a lot of Cisco boot camps. But right now, we're just going to talk about sFlow and how the SmartWall ONE looks at sFlow, collects sFlow, and the apps that ride on top. So I just have a few slides here, and then we are going to go through some more in-depth examples. And then hopefully, if I get through this pretty quickly, we'll have time for questions that may go over. We'll see. So without further ado, so the main two sampling types that we use, and these are the terms we use. So depending on maybe your vendor or background, you may use slightly different terms for these, but these are the terms I'm going to use during this webinar. So there's flat and relative. So when you're sampling something, you can take a flat sample. And that means no matter how large your data set is, I'm just going to grab a certain amount. So an example is I want to grab 4 people out of every city. The size of the city is irrelevant. So that means whether you're sampling, let's say, a large city like Paris or a small city like Rochester, Minnesota, you're going to grab 4 people. This means uh, it's pretty easy to explain, but may not indicative of what actually is going on. So relative is a fixed rate, meaning same thing for every city, you're going to do a sampling structure, but I want to do 1 out of every 5,000 people in that city. So in the above case, of course, I would have a lot more samples out of Paris than I would out of Rochester. So that's true with just all sampling. So for DDoS, there's some extra things that make sampling interesting. Um, but still, just talking generically, when I do a flat sample for anything in IT, one of the best positive things about it is that it is flat, meaning I know the exact number of samples I am going to have at the end of the day, week, year, or however long you want to do it for. This means when it comes to calculating storage or retention, you can use some pretty simple math and figure out how much space you need, cloud, hard drive, whatever. Also, when you're trying to perform analysis on this data, your query times are pretty predictable. Now, there's some stuff with metadata and how maybe your analytics engine stores data like cold bucket or warm bucket like Splunk does. But basically, you kind of know the size of your data, so your query times are going to be pretty predictable based on your time window. Now, the danger, and this is what I'm going to try to get across in a half hour here, is that each sFlow isn't really equal. Uh, take the samples I talked about before. If I take 4 people from a small city, and 4 people from a large city, each one of those people is actually representing a different amount of people from their home city. So, given the same sample rate, let's see, Paris is about like 100 times bigger, 1,000 times bigger than most of the small cities you might be thinking about. So, each one of those people that you take is representing a much larger group, possibly hundreds of thousands of people from their home city. So when you do this, normally you have to kind of insert some metadata into your records or have different messages that go alongside your sFlow to let people know that, hey, this person actually is representing millions, where this other guy is actually we're just kind of representing 3 guys. So now some people say, well, you don't need to do that. You could do a relative sample. So if I just take a fixed rate of, let's say, 5,000 to 1 or 1 out of every 392, whatever rate you want to pick, that means when you have more traffic or more people, you will get more samples. So if I'm doing DDoS analysis and I see a big spike in sFlow samples, that means I had a big spike in traffic. So the human brain sees that and goes, oh, yeah, that makes sense. Uh, Unfortunately, you need to store that somewhere. You need to analyze that somewhere. So when it comes to storage and retention, if during some parts of your day you're going to have 1,000 times more data than you did at other parts of the day, again, we're talking about DDoS analysis here, that is a tough pill to swallow when you're trying to develop the rest of the product. So hopefully you can somehow get this data, but not have it overwhelm your system. You don't want a DDoS on your network to become a DDoS on your analytics. Um, so that's the downside of a relative sample. So to give you more concrete examples, I just have to do a quick overview of the Corero solution. Um, it's just how we gather our samples. So at the ground level, we have the actual box that blocks the attacks. This also, while it's passing all the network traffic, blocking it, whatever, every single packet that goes through the box, it has a chance to be randomly sampled, right? Our sampling is very good, it's very consistent, and it's a relative sample. So more traffic goes through, more samples are created, right? Those samples are sent to our management server. So our management server does obviously config management, but as far as sFlow sampling, it does 2 things. The first thing it does is it takes all those relative samples that I got from my NTD and it picks 5 by default a second and sends them to the SWA. This would be a flat sample. So it doesn't matter whether you're under DDoS or not, lots of traffic or not, you get 5 per second. 5 individual sFlows a second get sent to analytics, right? Now, also at the end of the minute, the CMS uses all of the relative samples it got to make some metadata. So it'll take all of the sFlow it got in the minute and say, well, I can't send all these to the SWA. It's too many. I might have tens of thousands of them, hundreds of thousands of them in some cases. But what I can do is make some metadata like, hey, what were the top 10 source IP, dest IP, source port, dest port, packet link, TTL, and a bunch of other stuff. There's a lot of these metadata messages off the sFlow. And what they do is they help you characterize your traffic, especially when it comes to DDoS, right? And it does that once a minute and it sends those messages to the SWA. Now, what the SWA does, it's our analytics engine. It runs on top of Splunk. So we've used Splunk with this product from the beginning. Uh, it's included. Um, I'm really a Splunk fanboy. I think it is really intuitive. The full search capability is there for customers and us and the SOC that we use to support your product. But for now, before I get overwhelmed, I'm just going to talk about the events and the charts page. So those messages that come from the CMS, if you want to look at the flat samples, we have an events page. If you want to look at the metadata, the once a minute messages, we have a charts page. And those two together can really help you find anomalies and then find out if those anomalies are expected, not, are they attack traffic, need more analysis, whatever you want to do. Now, there's some other pages that I might show because people might have questions. So I might end up showing some other pages. But there's so many dashboards and other ways to view this metadata in a half hour. No, that's not happening. But we'll start with the simple stuff. So here is the events page. So there's a lot of stuff on here. Really, I'm just trying to show you that blue bar up top. So as all the sFlow comes in, our events page will just plot this over time and count them for you. You can't really see that number probably on there, but it says 25. The reason is with this time interval, Splunk has automatically chosen a 5-second time interval. So 5 a second times 5 that's the 25. Um, and you'll see that it's just a flat line across the top because it's a flat sample. Now, another anomaly you may see in there is I have a red spike in there. That's during my 30-minute window. I launched like a really quick, large attack. Um, that red line is part of the metadata messages I was talking about. It still didn't change the sFlow count. Doesn't matter if the attack was 20,000 PPS or 200,000 or 2 million, the same sFlow count would be there, 5 a second. Now, what this may help you do though, is this data that you see, this red spike, it may help you drill down on your sFlow and see what the anomaly is. So right now you see like a bunch of, you probably can't see the numbers, but I have like top source IP, dest IP, and so on. And those are over the whole time frame. So if I have time, I may get back to this, but when you're trying to find an anomaly on a flat sample, like I said, every sample is its own little picture, meaning it could be from something like Paris or it could be something from a small city. So as far as this page is concerned, everyone is equal. When actually during attack time, some of these samples represent a lot more traffic than others, right? And without extra data that I'm going to show you, you can't see that here. This is just strictly a count. This page is mostly meant for analysis like, hey, when I click on my top dest IP, is all the source port 80 or is the source port like 123 or is the source port something different, right? It's more of analysis of an anomaly, not really finding it. So when you need help finding it, that's what the charts page is for. So the charts page is built off once a minute messages, so it's much easier to search a longer time frame, but also it's built out of the relative samples from the CMS. This means shorter attacks have a much better chance of catching the human eye than trying to find them on this events page, right? Shorter attacks on a flat sample system get washed out. They're harder to see. Large attacks on a relative system do not have the same problem with washout. Now, if you search like a day or so, then yes, you would eventually get washed out. So you kind of have to know at least what day it happened on. But in general, relative samples are better at showing this, right? So that's the charts and events page. And this charts page, I'm just showing you 3 of like the 40 some charts that we have. I couldn't fit them all in there. All right. So that's the first piece here. I just want to make sure everyone's here. Okay. So if you have questions, go ahead and post those. I have people looking at those. Um, I'm going to try to show you a little bit more technical detail on how the sampling actually works. So this sometimes takes a few times to get, so it is recorded, and we'll ask questions about it. So I'm going to see if I can share this over here a little bit easier for you guys. All right, let's see. Okay, I just want to give it a while, make sure it updates it correctly. Looks like in the presenter view, it's fine. So, all right. So here's our 3 pieces. The NTD, which is responsible for blocking the attacks and sending the relative sample to the CMS. The CMS, which collects all the relative samples and performs a metadata analysis and a flat sample to the SWA, right? So as a promise I made to an engineer, and I drew this diagram a long time ago, you will notice that the bad traffic goes through the NTD. And that is because this NTD is in monitor mode. So Corero, when you deploy a device, you can set it to mitigate, meaning block the attacks, or monitor. Either way, the sFlow sampling, all the analytics works exactly the same, except we basically tell you, hey, in the end, we didn't actually block this. So I just promised him, because when the engineer saw the bad track going through the NTD, he was very upset. So I promised him whenever I showed this, yes, even years later, that I would always say it was in monitor mode. So here is the traffic going through the NTD. So I'm running 80,000 PPS of good traffic, right? So by default, and I'll pause this for a second here. By default, our relative sample rate on the NTD is about 1 out of 2,000, right? So that means if you're running 80,000 PPS, about 40 relative sFlow samples are sent from the NTD to the CMS a second. So 80,000 divided by 2,000. So this sFlow sampling is very random and very good. Um, this is something that Corero did right from the start. It's awesome. The statistical analysis is excellent. It gives you a great view of your network. We use it for countless products. But so we get 40 a second going to the CMS. Now, when that 40 a second piles up over a minute, right? That means over the minute, the CMS will have 2,400 good samples on it, blue, whatever you want to call them. Now, during the minute, the CMS every second picks 5 randomly out of that 40. So that's the flat sample, and sends them to the analytics. So every second, 5 go to the SWA. Boom, 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 right? Now, over the minute, the SWA can now look at these when you basically look at your events page, and it can count these, and it would say, hey, I see 300 good samples, right? So at the end of the minute, right, you'll see 300 out of 300. You'll see 100%. You'll see on the charts page 100%. So if your charts page looked kind of boring, you would just see one blue line all the way at the top. And I didn't really talk about the overview page much, but it's basically an interface graph and some other stuff. It would say, hey, I saw 80,000 PPS. So that's pretty standard, nothing too fancy about it. Does that make sense for people? I hope. I'm debating whether I want to answer questions as I go. Okay. I'm seeing some questions. I will answer those at the end. So I had a feeling that once I showed this, this is when the questions would happen. That's good. So I'll answer them. Don't worry. So this is the good case. This is the background case for your samples. So 80,000, you end up, all your graphs line up. They're all blue. They're all happy. Everything makes sense, right? So this traffic, let's say, gets replicated in my second example. So my second example, I'm going to have 80,000 PPS again, right? But this time during the whole minute, I'll also have 20,000 PPS bad traffic, right? For a total, obviously, of 100,000, right? So here's the thing, it takes a while to learn. And each of these kind of build on each other. So I want to make sure I say these a little bit slower, right? When it comes to a relative sample, when you add more traffic, the existing samples that you have will not be changed because it's relative, right? So just like in the last example, when I had 40 good samples being sent from the NTD to the CMS, doesn't matter if I add other traffic on top of that. That will not change. It's the same. It's a relative sample. Now, in addition, I have 20,000 PPS bad traffic. So now I'm getting 10 bad samples a second also sent to the CMS. So makes sense. I'm doing 1 out of 2,000. I have 100,000 PPS. So that should be 50 samples a second. That's going from the NTD to the CMS, right? Now, the CMS every second has to pick 5 of those and send them to the SWA. These are randomly picked out of the stuff that came in that second, right? So since about 1/5 of the traffic is bad, it makes sense that a good random sample, which the CMS is, will send 5 a second to the SWA, and 4 out of 5 of those will be good. 1 out of 5 of them will be bad, right? So At the end of the minute, after the CMS is done and the attack and all the good traffic has gone through, and you look at your graph, you would see on the overview page, it would say, hey, in this minute, I saw 100,000 PPS. Makes sense. You had 80 plus 20. If you log on to the events page, it would say, hey, I see 300 samples. Every minute, the events page will always say 300. It's a flat sample. The amount of traffic is irrelevant, right? So it's going to say 300. It's going to say, hey, I saw 80% good and 20% bad. When you look on the charts page, it'll also say the same thing. You'll have a blue line around 80% and a red line at 20%, and it'll say, hey, I saw 80% good, 20% bad. Everyone agrees, right? In the world of perfect mathematics and attackers attacking exactly on minute boundaries, all the math works perfectly. Yay. So if you're testing a system, you can do this. It works great. But it's not realistic. So um, attacks don't have to fall on a minute boundary or even last a minute. So here is the same exact background traffic I did before. No change, 80,000 PPS, right? And it's running over the minute. And then what's going to happen is 8 million PPS bad traffic is going to occur for just 12 seconds, right? So this is a lot of samples because, again, it's a relative sample from the NTD, right? So while that attack is going on, you're getting 4,000. Remember, it's 1 out of 2,000, and I'm sending in 8 million. You're getting 4,000, quote, bad sFlows a second going to the CMS, right? You still get the 40 good ones. Again, when it's a relative sample, adding more doesn't change what was there before, right? So when that 8 million is coming in and the CMS is basically getting almost all bad samples, when it randomly picks the 5 a second to send to the SWA, pretty much for that 12 seconds, mathematically, pretty much all of them are going to be bad. Like all 5 out of 5 are going to be bad. You might get lucky and get a good one in there, but statistically, no. They're all going to be red. They're all going to be bad for that 12 seconds. Once the attack is over and the minute is still progressing and your background traffic is still running, the CMS is only receiving good sFlow for the remainder of that minute. Therefore, all the samples being sent to the SWA for the rest of that minute are blue and are good. That means that when you look at all of the flat samples over the minute, 240 of them are good and only 60 of them are bad. That is the inherent danger of only looking at a flat sample. This has the same events page look, for the most part, that the previous attack had, where you had 80% good and 20% bad on your flat sample, right? Now, don't get me wrong. There's plenty of other things on our CMS and SWA that would let you know that this is not like last time, including our charts page, right? The charts page is built from the relative sample, which was overwhelmingly bad, right? There was 8 million PPS that totally dominated your traffic over the minute, right? Even though it only happened for 12 seconds. So if you look on the charts page, it looks at the 50,000 some samples it received over the minute and goes, uh, only 2,400 good samples over 50,000. Wow. That's a very small percentage of good traffic. The rest is bad. Now, to make things more interesting, when you look at the overview page, and this is another problem that networking and DDoS have all the time, it'll say, I saw 1.68 million PPS. And that is because with most graphs, there is an averaging going on somewhere. And depending on your vendor, it could be 1 minute, 5 minutes, an hour, who knows? In this case, on our overview page, we do once a minute averages. So the average PPS over the minute was 1.68 million PPS, right? So this is a more realistic example. And this is an easy way to highlight the difference between a relative and flat sample and why you need both. You need both because the relative sample can help you tell where to look. And it'll tell you that the 60 bad samples you're seeing in this minute are much more important than the 60 bad samples in the last example. Right? So that's the combination. All right. So maybe some of you can review that again, but I will, in the interest of time, I want to try to get to these questions I saw. So first guy says, how do you deal with burst attacks? I'm assuming you mean on sFlow, which is kind of the example I just did. If you're talking about mitigations, that's a little bit different. I don't know if you have my email. Maybe we can discuss that offline. But when it comes to just the sFlow, which this webinar is about, yes, if you get a burst attack and it only lasts like here for like 12 seconds, on the events page, it'll be very hard to see. But on the charts page, it'll be there. As far as mitigations, our mitigation timers are sub-second. So you'll be okay there. But I don't want to go into that. The second question I got here is, how will this work in case of a hit and run attack? I'm assuming that's a similar question. So these are more mitigation type questions, which I like, but I can't really go over here. I don't know if there's other questions people have. You can just post those. I will show, let's see if I can, I think this might be what someone's asking. Hold on. I will see here. Okay, let me see if I can share this screen. This might be what the person is asking. I'll make sure this loads up okay. So here's an events page, kind of like the picture I sent you. Maybe now it's a little bit easier to see. So this is the blocked packets that you see there. And these are from the flat sample, just telling you the top, right? So here's the top destination IPs. If you're trying to find an anomaly or an attack or interesting traffic, the best advice I can give you when using any system is there's two problems you can have when looking at a flat sample. One is you're too far out, right? So let's say this attack looks like it's pretty short. And let's say I try looking over 8 hours. There's no way that guy will be in the top 10 for basically anything. So this attack, is it one of these IPs? I don't know. Now on Corero, you can click around and try to find stuff, right? So you can just click here and it'll do the search over again with a drill down. And obviously, when I look at even my flat samples, odds are it probably wasn't that IP, right? And you can kind of click around and try to find it that way. But really, a better way of doing it would be to come over and look at your charts page and get more information, and then use that to come back to the events page and kind of drill down. The second problem, which I don't show here, is that if an attack or some kind of traffic you're trying to investigate has gone on for a long time, you may be inside the anomaly. So when you go to look at a flat sample and you're like, oh, like this, take a look at this traffic here, right? It's going on in my whole time window. You're like, oh, that's baseline. Well, it's baseline for the time frame you have selected. So sometimes if a customer or a partner wants you to analyze something and they say, oh, it happened yesterday, maybe it happened for 4 days. And when you're trying to find the anomaly, you can't because you're inside it. That's probably the two biggest hints I can give when you're trying to use something like this. So, oh, looks like I got a. Oh, okay. Now someone just answered that question. It looks like I answered that one for you. So, but yeah, that's technically the half hour. So if you guys have other questions, I don't know if it goes through this system, but you know who I am. So some of you, I recognize some of the companies here, so you know where I live. You can just send me the stuff. So, but that's it for the sFlow analysis. Hope people got a little indication on the sampling types and how you can use both, and definitely in a combination. So keep searching.